Okay, so what we've got now is we've got the atomic structure, the physics unit, in Key Stage 4, keywords to learn. The rate at which an unstable nucleus decays. So when the nucleus of something radioactive decays, that is called its activity. A positively charged particle consisting of 2 protons, so 2 protons and 2 neutrons, and is often called a helium nucleus, so it's just the middle, it's not the electrons around the outside, is an alpha particle, and it's often written as alpha 2 plus, okay, because it's got 2 protons in there. The number of protons found in an atom of a specific element, each element has a different atomic number, right? Tells you the actual answer there, which is a bit silly, atomic number. Radiation that's found in small quantities all around us and originates from natural sources of rocks and cosmic rays, as well as from man-made sources such as nuclear weapons. Okay, it's background. It's the stuff that's hitting you literally all the time. The unit of radioactive activity is a becquerel, written sometimes as BQ. A high-speed electron that is nucleus emits from a neutron converts into a proton is a beta particle. It's kind of like I'm terribly drawing this. It's like a bee with a tail on the end of it, beta. The model of the atom that suggests that electrons orbit the nucleus at set distances in shells, that was Bohr. The number of decays that a detector measures per second is the count rate. A negatively charged constituent of the atom that is found in different energy levels around the nucleus, an electron. The stable states in which electrons are found around a nucleus, so you've got your nucleus and then you've got your electron shells around the outside. They are the different energy levels. Okay, so then you got electromagnetic radiation emitted from the nucleus, often a wave like that, and that is a gamma ray. A detector that measures the count rate of a radioactive sample is a Geiger-Müller tube, or sometimes it's just called a Geiger counter. It's one of those devices that kind of makes that clicking noise you see on TV programs. The time it takes for the number of unstable nuclei of an isotope to halve, or the time it takes for the initial count rate to halve. So if it starts at 100 count rate and it goes down to 50, that's its half-life. Atoms are a resultant charge due to the loss or gain of electrons. So it could be F- or Na+. So F- has gained an electron. Sodium, Na+, has lost an electron. They are ions. The process of an object being exposed, okay, so this is exposed to, so that means it's kind of not actually touching you, right? It does not become radioactive, is irradiation. Atoms with the same number of protons but different number of electrons, so 7, 3 lithium, 8, 3 lithium. It's got the same number of protons, but then it's got one more neutron with the 8. That's an isotope. The number of protons and neutrons is an atom, so that's 7 there, tells me it's got 3 protons plus 4 neutrons. Atoms that gained electrons, so have a negative charge, so F- has gained an electron, that's a negative ion. The neutrally charged constituent of the nucleus is a neutron. The positively charged center of an atom, so in the middle of the atom itself, the little dot in the middle, has got protons and it's got neutrons, and that is the nucleus. An old model of the atom that represents the atom as a ball of positive charge, so it's a ball of positive, with negative distributed through it, right? So what it's supposed to do, it's supposed to look a bit like a Christmas cake, which is the plum pudding model. Some people say it looks like a chocolate chip cookie. Atoms that have lost electrons, so Na+ has lost an electron, giving it a positive charge. That's a positive ion. A positive charge constituent of the nucleus is a proton. The unwanted presence of radioactivity on other materials. So if the radioactive material actually touched me or went into me, right, that is radioactive contamination. The random process involving unstable nuclei emitting radiation to become more stable is radioactive decay. And the unit for radiation dosage, so this is how much you're allowed to have, is sieverts. Now what you need to do is you need to pause on the next few slides, the next part of the video, and test yourself Right, write down your answers onto a piece of paper. Hopefully you got the vast majority of those right, even all of them right. Okay, but what you now need to do is you now need to do it again. Okay, having done it a second time, right, hopefully you've got maximum marks on it, right? But again, what you got to do is you've got to make sure you come back to it again, right, in the near future. Okay, it doesn't take long to do.